So now we're going to look at graphing the other four trig functions. So secant, cosecant, tangent, and cotangent. We're going to start with secant and cosecant because they're pretty similar to sine and cosine with how we're going to graph them. A few quick things though about secant and cosecant. Remember that secant is the reciprocal of cosine, right? So secant is 1 over cosine. Cosecant is the reciprocal of sine. So cosecant is 1 over sine x. Now, because we have these fractions, right, we have to worry about when the denominator is 0. So whenever cosine is 0, secant is undefined. And whenever sine of x is 0, cosecant is undefined. So just to kind of put that info kind of together, places on the unit circle where cosine of x equals 0, which means secant would be undefined, those are at my pi over 2's. So pi over 2, 3 pi over 2. If I kept going, 5 pi over 2, on and on and on. Places where sine of x equals 0, that's what makes cosecant undefined. Those would be at my 0 and pi's, right? So 0, pi, 2 pi, 3 pi, on and on and on. So we deal with graphing undefineds with asymptotes, right? So we're going to have some vertical asymptotes here. And let's go ahead and jump into talking about graphing these things. So same setup that we're used to seeing, right? There's my A, B, C, and D. Now, before we kind of talk about all this stuff, it's important to note A behaves very similarly to what we've looked at with sine and cosine, right? Sine and cosine, that was our amplitude, right? But the amplitude is my distance from the midline to my max or my min. And that's only the case for wave-like functions, right? That's what the amplitude is. Secant and cosecant don't have amplitude. You'll see once we graph it, the shape is not something that has an amplitude, but we still describe A as, A, and it still kind of behaves the same. It gives us one of our main points that we need. So we're still going to identify A, but it's important to note acts similarly to my amplitude, but it is not actually an amplitude. And that's the case for all four of these functions we're going to look at. So secant, cosecant, tangent, and cotangent. Okay, we're still going to identify what A equals. We're still going to use that to help me graph, but we're not going to call it amplitude anymore because it's not an amplitude. So the way we're going to graph secant is we're basically going to do what we've been doing. We're going to graph cosine, just like we've been doing. And then from there, we're going to kind of make the graph of secant. Like I said, they're directly related. Since they're so similar, one's just the reciprocal of the other, they have a lot of similarities. So we're going to start by graphing y equals cosine of x. We're still going to use MAPI, right? Just to kind of show that information for this. For cosine of x, midline 0, amplitude 1, no phase shift, my period is 2 pi over b, and my interval is 2 pi over 4, so we move by pi over 2's, right? So all that's the same we've been looking at, right? So pi over 2, pi, 3 pi over 2, 2 pi, going in the negative direction, just to kind of show you that as well. and my amplitude is 1. Okay. So cosine, no phase shifts, midline is here, right? And with cosine, we start at the maximum and then follow my pattern. Minimum. Going in the negative direction, just follow that same pattern. And I like to make it a dotted line because remember, we're not graphing cosine, we're trying to graph secant. That way I don't get confused. If you're using colors, that helps. If you don't want to do a dotted line, if you're just using one color though, that kind of helps. So you don't have all of these solid lines everywhere. So graphing cosine, I would have this. All right, so there's cosine of x. Now, let's look at secant. Again, we're still doing MAPI. All of that stuff's going to be the same, right? We still find the period by doing 2 pi over b. We can write that here too if you want to jot that down. It's the same. Period is still 2 pi over b for secant and cosecant. Now, with secant, I am worried about when cosine is 0. So that happens here, here, right? My pi over 2's. So anywhere we have a pi over 2 where that doesn't simplify, when I'm on that x-axis, that's when cosine's 0. And that gives me undefined for secant. So that is where I'm going to have my asymptotes. Okay. Now, graphing secant is fairly easy now that we have all of my info there. What we're going to do, that a value, so here a is 1, right? I'm still going to utilize those points that I find from my amplitude of cosine. But now I'm going to have what look like parabolas from those points pointing away from my x-axis. And it keeps going. Like that would keep going that way. If I kept building my graph out that way, that would keep going on and on forever. So the cool thing about secant and cosecant, when you think about the fact that secant is the reciprocal of cosine, right? So we flip my cosine of x over 1, I flip that fraction. This graph is literally that. If you look at this interval right here, if you think about the cosine graph, that's that little parabola there, right? I'm literally just flipping that thing up. So that's a pretty cool thing to look at and think about. So that's secant. We're going to do the same exact thing for cosecant. So cosecant, again, that's related to sine. So we're going to focus on graphing sine, just like we've been doing. So let's look at sine of x. Again, I'll do the MAPI thing just to show that we kind of do the same thing. Midline 0, amplitude 1, no phase shift, 2 pi over b, and then interval 2 pi over 4. So building my graph here, we're going by pi over 2's. Negative direction. Amplitude for sine, 1, negative 1. And for my sine graph, we start at the origin, right? We start on my midline. and do my sine pattern. So max, midline, min, midline, negative direction, down, midline, up, midline, and kind of lightly draw that graph in there, just so we can visualize what's going on. Okay, so there's my sine graph. Now, let's think about cosecant. So again, I want to think about when sine is 0, right? That makes cosecant undefined. So that's where my asymptotes go now. Okay, and then same thing as with secant, right? That a value, the amplitude of sine, that gives me those starting points for my parabolas, we'll call them that, okay? That's what they look like. So I have this as my cosecant graph. So eventually we'll get into introducing, phase shifts, moving the midline, right? But again, as long as you relate it back to sine and cosine, it's not really anything super new, okay? We graph sine and cosine just like we've been doing, and then once we have that built, we just throw in our asymptotes and then flip up, basically, and down our peaks and valleys. So that's cosecant. So we've looked at secant and cosecant. Now we're going to kind of switch things up a little bit and look at tangent and cotangent. So tangent and cotangent tend to be a little bit weirder, mainly because they're not directly linked to sine and cosine, which is what we've kind of built everything on so far. They do have similarities, and we'll talk some about those in class, and we'll go into much more detail on dealing with phase shifts and things like that for tangent and cotangent, because it is a little bit different. So in this video, we're mainly going to focus on building and identifying the parent graph and the unique features with tangent and cotangent graphs. We're not really going to get too much into how we handle phase shifts and things like that until we're in class. So it's super important that you get this information down and you're comfortable with it before you come next class, because we're really going to dive into kind of some tougher, harder problems to kind of visualize and think about with tangent and cotangent. So just to remind you about sine and cosine, tangent and cotangent. Tangent is opposite over adjacent, right? So if I think about that in terms of sine and cosine, tangent of x is sine x over cosine x. And then cotangent is the reciprocal of that. Okay, so cotangent would be cosine of x over sine of x. Again, because I'm dealing with fractions here, I'm gonna have those undefineds, which we've, evaluated and found in previous units. But now we have to deal with graphing these and dealing with those undefineds. So again, we're gonna have some asymptotes here. So let's look at tangent first. We are still going to make use of our acronym, right? So M, A, P, P, I. But again, remember, A is not amplitude. It behaves similarly to how we would think about amplitude when graphing, but we don't call it amplitude, it's just A now, okay? And with tangent and cotangent, the A value helps us to identify where our key points are going to fall on my y-axis. So that's really helpful to know. So let's look at graphing tangent of x. Again, just to show, I know these things are kind of basically all ones and zeros with parent functions, but just to keep the habit the same here. So my midline, my d value, 0. My a value is 1. No phase shifts. Now, period. Period with tangent and cotangent. To find the period, for these, we're going to do pi over 2. Or, sorry, pi over b. Okay, so it's no longer 2 pi over b. So we use 2 pi over b for sine, cosine, secant, and cosecant. With tangent and cotangent, to find the period, we do pi over b. So if I think about my b value here for tangent of x, it's 1. So pi over 1 would give me pi. And then my interval, I still do period divided by 4. So I would move by pi over 4s. So here would be pi over 4, pi over 2, 3 pi over 4, 4 pi over 4, which would be pi. And we'll go one more. 5 pi over 4, 6 pi over 4, which would be 3 pi over 2. And we'll stop there. Going the same in the negative direction, negative pi over 4, negative pi over 2, 3 pi over 4, negative, negative pi, 5 pi over 4, negative 6 pi over 4, which would be negative 3 pi over 2. And my a value is 1. Okay, so we're still going to use that to mark my y-axis. So we're going to go up to 1 and down to negative 1. Now, I have listed here my 5 key points of my parent function. And when we think about tangent, right? Tangent of x is sine over cosine. So when cosine is 0, that's when I'm undefined. So if I think about my unit circle, where cosine of x is undefined, those are my pi over 2s. So if you look here, so my pi over 2s, anywhere I see a denominator of 2, right, that doesn't simplify out, that's where my asymptotes are going to fall. So if I look at my table here, here's negative pi over 2. Here is positive pi over 2. Then I have my center point. So my center point. And then the way we're going to show this once we get into phase shifts, so next class, and we look at all this stuff, we're not so much going to build a table every time. We're going to look at my interval and my a. So my a is 1, and my interval is pi over 4s. So that means I'm going to be 1 step over and 1 step up, and that's where my point goes. Going left, we're going left 1, so left pi over 4, and then down to negative 1, which is shown here in the table, right? Then I draw my graph. Okay. Continuing the pattern, right? I see another pi over 2 over here at 3 pi over 2. So there's another asymptote. If I think about the middle of this interval, that would be right here, right? So the middle of your two asymptotes, that's where the center point will fall. for tangent and cotangent. And again, we'll talk more about how we'll find this when we're moving with shifts and all that in class. But for now, if you notice, if you think about this as one period, right? Here's another period. In between the two asymptotes is where the center point falls. And then based on your interval and your A value, that's where my key points go. Going left, I see a pi over 2, just to show it one more time. In between that period, like right in the middle, negative pi. And then my interval and my A value. So a pi over 4 to the right, pi over 4 to the left. And there is my tangent graph. Okay, so again, I would focus on kind of setting this up and try and bring this info to class with you next time, because like I said, once we start throwing in phase shifts and moving the midline, things get a little hinky with tangent and cotangent. All right, so last one, real quick. I'll do cotangent a little faster because it's very similar. It's just things are in different places because it's the reciprocal of tangent. So if I think about cotangent and what it equals, so cotangent is cosine over sine. So when sine of x equals 0 is when I have my undefined. Again, we have my key points here. So if I think about the unit circle where sine is 0, that happens at 0, pi, 2 pi, 3 pi, right? Anywhere there's just a pi or a 0 and there's no denominator, okay? Now, just to do the acronym one more time. A, zero, 1, no phase shift, period again, pi over b. So just pi, and then my interval, pi over 4s. So when I think about my table here, right, my key points, and I see that sine, right, sine usually starts here, right, because that's when sine's 0, that's going to give me an asymptote for cotangent. And my A value is 1, so let's go ahead and put that here and here. And then we'll build the x-axis. So pi over 4s. And actually, we'll stop at pi for this, for the sake of time. Going negative, negative pi over 4. Negative pi over 2, 3 pi over 4, negative pi. So, just focusing on the table, right? Undefined at 0, pi. If I went to 2 pi, it'd be undefined there, on and on and on. So anywhere I see pi is where I'm going to have an asymptote. Whoops, missed. Okay. And the same idea as tangent, right? So if I look at, here's my period, right? Look directly in the middle, halfway, right? That's where the center point goes. And because things are reciprocated here, it's the reciprocal, right? Think about kind of flipping tangent. If you think about the graph, right? If I flip that thing, that means I'm going to start here. And again, that's in the table here, right? Pi over 4, 1. 3 pi over 4, negative 1. So I have the, ooh, sorry, I got, okay. Showing it in the negative direction, there's my negative pi, so there's my asymptote. The middle, or halfway in that period between my two asymptotes, so there's my middle point. And then I do my interval and a value. So interval, a value. Interval, a value. And there is cotangent. Okay, so again, definitely make sure you come to class with at least some questions about this stuff, being a little bit familiar with why asymptotes are going where, because once we start moving this stuff, it's gonna get a little bit difficult, all right?